Alright, we're live. Okay, what are we doing?
Didn't I came over and you had a miniature experiment
Right, I want
or
to. Yeah.
demonstration of what we've been talking about before, where we're using a set of six parallel 1.4 volt batteries and a set of eight series
Yeah.
series 1.4 volt batteries. Well, this added to 12 volts if it were 1.5, but this is going to be this is going to be like 11 volts or something if you were to measure it at the leads, I believe. And then this one's just going to be 1.4 volts. And then you're going to put the negatives of these two together, and then the positives to the negative and the positive lead of this motor, and this motor is coupled to a generator. We're going to read how many volts we have here, and we're going to see if we get an increase when we connect it to the generator.
Mm-hmm.
That's what I think we're doing.
Okay.
What words would you use to describe it?
I like the words you used.
All right.
And so, if you want to learn more about this kind of circuit, look on Rick Friedrich's channel, and it's just charging parallel batteries with series batteries. To learn more about that, usually, I think in the diagrams it shows having equal numbers of batteries on each side, but I didn't have a 6 series battery set, so I just put more in. It gives us more voltage anyway. Okay, so let's go ahead and wire this together.
So you need a red.
Yes. Oh, you want to hand me the wires?
Yeah,
Okay.
yeah, sure.
Okay, so I'm going to connect the positive of this battery set into the negative of this motor, and then I'll connect the positive of this motor to the positive of the parallel set of batteries.
Is our meter set up at this point?
Not yet.
Okay.
Let's do that. So let's wire the meter up. So the meter needs a positive and a negative. And I forgot, what are we connecting to on this one? Oh, we're just connecting to the output of the generator, right?
We're gonna check it at the motor and then at the generator, but then we were talking. Well, I just saw these LED lights over here, and I said, why don't we connect that too? So
Yeah, these.
eventually we can connect that too and see if that increases the voltage. Sneak peek.
Yeah.
Joseph, do we do sneak peeks?
Sure.
Sneak
Yeah.
peek. Yeah, it does.
Yeah, it increased the voltage by connecting this. It didn't turn these lights on because this is a very low voltage system, but it did increase the voltage when we plugged into this. And LEDs are light emitting diodes, so I think there's a gap between them, right? They don't actually, nothing's directly touching. A diode, there's like
Nothing is directly touching,
it's,
right?
I think, with an LED, I think there's a little space in there. So that's why we called the video what it's called. Which Cameron came up with the name for this video, and I think it's a good name. Okay, we need more wires. The wires are on the side.
Yes.
Oops. The wires.
These ones here.
They're over there on that side. Over there.
Oh, gotcha.
And there's black ones below, black wires. And those are red lights and the black.
How many do you need for red for now?
I don't know. Just for now, just
Sure,
one at a
okay.
time.
Couple.
Yeah. So let's see. Negative. So I'm going to connect the negative of this set, which is right here, to the negative of this set. Okay, that makes everything turn on. So I'm going to take that off for now. So I can connect this. And then, so what is connected and what's not? Is everything ready? So
I think if you turn your meter on, it should read. The meter is connected to which right now? We've got lead of meter connected to the higher end, to the end, to the generator where we expect higher voltage.
yeah.
Okay. And we can also check it after with what would be lesser.
Okay, let me hand this to you. Okay, so we do have the stand for this now. Should I set that up? Or do we need it? It might help.
Either way, yeah. Do you think it attaches to that table?
I'll try. I'll see if it does.
Or you know what? Why don't I just hold it and you know,
See if it attaches real quick.
I bought one that exact mount before. I bought all these mounts like a year or two ago for my YouTube videos.
Oh, you did?
But I didn't end up keeping that because somehow it didn't like attach to everything I wanted it to.
Now let's see if I can do this. Let me try opening this. I need to get it. I need it to have some room to.
What about, can it go right here? That might be the spot.
I should have set this up before streaming. Alright, let's see. So I got that. Let's see if we can put this somewhere where it won't be in the way, but will also be in the front, where people can see it. I have to be careful not to short these wires out. That easily happens sometimes. Now there's just wires like everywhere. Okay, let's see if I can. Is this gonna work? Doesn't look like it's gonna work, does it?
If we get it a little bit, if it's down there, is that still safe? If we get it closer, yeah, there it's in the shot. That's pretty decent.
Okay.
And do we want this light aiming at it so that it's, or
It is. It's.
It is good
It's,
enough?
I mean,
Okay,
it's,
cool.
it's. Oh, this light is. This light over here
all
is.
right, cool. So the viewers at home can see it. That's good.
Okay, so let's slide these over here.
Do you have a name for this circuit? This what we've made here?
Rick Friedrich calls the circuit basically with the batteries charging batteries, series and parallel. He calls it the loving giving path.
The loving giving path.
Yeah.
Okay, gotcha.
Versus the selfish, ungrateful circuit, which is a less, I guess you could say, a less efficient circuit.
Okay.
I mean, it wouldn't produce these results, at least, from what I understand. Okay, so let's see. How's that look?
So what's the meter connected to right now?
Right now, the meter's connected to. Oh, is it showing?
Ooh, is
There
this
it is.
table gonna ground by any chance? Sorry to black the camera.
I think it's painted,
Okay.
so I don't think it will. But if we see sparks or voltage dropping, then we'll know it is.
Okay.
Cool. We actually have a meter we can read right now.
And it's connected with the positive of the meter going
to the generator.
to the generator.
Yeah.
Okay. And what is causing why is the generator not running right now? Because this
That's
is not connected
yeah.
to. Okay.
The positive is not connecting to the
Okay.
other positive.
So
This
we're
set-
going to observe voltage
Yeah.
off the end of the generator, and then we can test it against the end of the generator and adding in this LED light and see if
Yes.
it increases.
So the power source right now is AA batteries in series, AA batteries in parallel. These are at 1.4 volts total because all the negatives are connected together and all the positives are connected together. So all the negatives, all the positives. And these are in series, which is when you connect positive to negative and then positive, negative, all the way through. And at the end, you connect to these two leads, which are going to positive going through this motor, and both sets of batteries, the negatives are connected directly together. Just the positive, it's called splitting the positive. Just the positives are separated. And somehow that reads as positive and negative on each side of this motor, which is interesting. So, shall we go ahead and run it?
I'm dying to see it happen.
Okay, so let's see what voltage we get when we coming out of this generator. I'm calling this a generator. It's a servo motor. It's like a 25 volt servo motor for aerospace. It's something related to jets.
Mm-hmm.
Okay, so, but any generator motor can be used, any motor. I'm just using this. any motor, brushed motor, can be used, I think. Okay, so I'm going to go ahead and connect this and see what our voltage is.
24, 25.
That's pretty high.
Okay.
That's a pretty high voltage.
I propose we stop it and add the spark gap LED in the middle. That's what I
Okay.
propose. Do you want
Yeah,
a
I
red and a
thought.
black?
Hmm?
Do you need a red and a black?
Well, this is
clip?
still connected from earlier,
Okay. Oh, okay. Gotcha.
so I'll just connect this to. Well, I'm trying to remember how we did this. So I'm gonna go to the. Oh, directly to the generator. Go directly to
But in between it, you could. Or no, you're gonna measure the voltage in between it, though, right?
Mm-hmm.
Okay.
Yeah, I was just trying to remember.
You just attach the clips directly to those.
There's so
red
many
and black.
wires.
Yeah. Yeah.
They add up quick. The wires add up fast.
And right now, what are we reading on here? We're not reading.
Okay,
anything
so
to speak of.
when we turn this, so now the generator is connected to the LED to this LED light, and the LED light won't turn on. But when we connected it earlier, the voltage increased. So let's see what it does right now. Let's see what we have. Ready?
Ready.
Oh, the light turned on.
Whoa, the light turned on this time. It's
didn't
different
turn on?
results than last time.
Yeah.
Last time we had 20 volts off the generator, and then we had 26 volts off the light. But this time the
wonder
light's
why-
running.
I wonder why it did that. And look, we're still at 12 volts.
It's at 12,
12.4
volts, which, okay.
That's still higher than these altogether, isn't it? At 1 point. Oh, this is getting hot because there's a load
Oh,
on
okay.
it.
It was getting about 8.9 volts at
That's kind of amazing.
the positive and the positive. Okay, how long do we do this for?
Yeah, so this is hot. It's still higher voltage, but this is getting. These are getting hot because there's a lot of.
It feels like it's slowing down a little bit.
The ends of these are getting hot. They're not made to for this much power. Okay, well, I don't know how we can do our original test.
Well, you know what? Repeatability in science, we just debunked repeatability right there. Because this is why we always have to turn the camera on before we do anything. Because it. Wow. Okay.
Okay,
I
let's
am
hook up.
surprised.
I'm gonna hook up a different set of
Awesome.
LEDs and just see what it does.
Awesome.
I just want to see something close to what we got before.
Yeah.
You know what that reminds me of? That light coming on the second time, when the when the fluorescent bulbs, when I'd first turn them on, even with the high voltage system, which is 475 volts,
Mm-hmm.
the first time I'd turn them on, well, not at 475, on low, on 475 it would turn on, but at 350 I think it was, they wouldn't turn on. I could turn it on and off, it wouldn't turn on. But the second time, it's almost like it primed it.
I want to get potentiometers in
Yeah.
the mix of everything we do. You know those cheap lamps outside on the side of the curb? You know the little potentiometer
Yeah.
that goes bright
Yep.
to not bright?
Yep.
We need to get those, put a
Yeah.
potentiometer in here, put it everywhere. Let's
Yeah.
get potentiometers everywhere.
Yeah. Let's see what this does now. So now we just hook up a different LED. We hooked up this one.
Which is probably also a 9 to 30 volt, relatively cheap, not mega power light. Wow, that's very
Darn.
bright.
It's lighting. Oh, I should be happy it's lighting it, but it's.
And it's now showing 8.9, and it's a lot lot brighter. This one is significantly
This is super
brighter.
bright, yeah.
And
It's kind of
this
amazing
is-
that we're powering that with little AA batteries, isn't it?
How long can we do it for?
Well, it's limited
Ooh,
by
what
by this.
Hey, let's
This
power it
connection.
off. Let's power it off this. Can these lights turn on with the positive of this guy and the positive of this guy, and not with your generator connected? You know what I'm saying?
Let's see. Oh, because you're.
Will it
yeah, I
work
see what you're saying.
Generatorless.
So are we
meaning,
taking-
is this generator necessary to make these lights work today? Let's prove it. Can this light run
Just by the circuit alone.
Just by the circuit, not with the
Because
generator.
the circuit itself is an efficient circuit. It is an efficient circuit. And we go to Rick Friedrich's channel to learn more about the loving giving path circuit. I'm just calling it that. The circuit goes way back. He learned it from other people, engineers that were doing this for a long time. So I'm going to go to, let's see how we're doing this. Let's see, so negatives, so anywhere in this line, I guess. Well, let me try this side first.
Yeah, this side, so it's not running this
Let's try this.
motor.
I think it has to be connected, right? It has to be connected.
Well, I'm thinking
Look, it's not doing
this-
anything now.
this lead. Yeah, this lead to that.
It's not doing anything.
Oh, and then this is connected to the other side of it. This black. No, I'm thinking this one goes to.
Oh, to each side of the circuit. Oh, each side of the circuit.
To this thing.
Yeah.
Okay, there it is. But is it as bright? And what does this say? This is showing 8.6, and it's less bright. It's noticeably less bright, and 8.6. Do you think it's noticeably less bright?
I can't tell, but it's neat that it's working. I mean, it's neat that we're running this LED lights with AA battery. That's a pretty. What is this
What
for? Is
about-
this for cars or what's
Yeah,
this
it's
for?
car fog light. Well, what about this one? If you connect
Yeah.
this one, do the same thing.
Let's see.
Will it run? And to the folks at home, see it. Can I? Maybe I need to bring this over.
Yeah, just right there.
Here, I'll bring it in view so people
That's
can
in
see it.
view. That's in the
Okay.
frame. And same thing. Go to here and here, right?
Yeah. Oh, it's just barely.
That's
It's
very
just barely. And before it was properly on, and the voltage showing is 8.7 something.
So from the
Right.
generator, we're getting a higher voltage,
And better light function.
which that sounds pretty good to me.
It does. And hey, with that, let's get some tacos and nachos.
So
Red
I'm gonna go.
scooters.
I'm going back to the generator now.
Oh yes, and on this one I'm holding. Let's see if it's brighter.
Yeah.
Awesome.
Look at that.
That's
Wow.
brighter. It is
Look
brighter.
at that.
And the voltage running at 12.58
From the generator.
from the generator.
That's pretty amazing.
My brain still wants to have a side-by-side demonstration of this setup and then also the dimmer setup and just see how long does each one run, all that stuff. But for now, I think that was pretty proper.
Well, even if the dimmer
Demo.
one ran longer, it's like, what do you want? Do you want longer run or do you want more brightness?
I want more brightness for sure. I want extra brightness, really. Let's run it. We need to get something that's between this one and your other one so that we get extra brightness. You know, get it at 30 volts coming off.
Yeah. Okay, so we couldn't show our multiplying voltage. Are we going to have to change the title now?
Did we multiply?
Yeah, I mean, did we? Oh, yeah, maybe we did. But did we do it with LED? Oh, are you saying the LED is what allowed the brighter, the combination of this
okay.
circuit, the combination of this circuit,
Plus
which
an
is
LED.
plus an LED. Do you think that's part of it?
Well, in my discussions with you and everything you've read, that's what I would believe. We could try next time with an incandescent bulb in there and see what it looks like. Is that because that's not an LED and that's not a spark gap device?
Yeah.
But then, you know, again, we did this without the camera on. We got a different result. We put the camera on. We got, you know.
Well, what we got was this light didn't turn on, but our voltage jumped up like 4 or 5 volts.
By this line.
This light,
This
yeah,
light, yeah.
early. So before we stream this, we plugged this light into this generator, and we got an increase of 5 volts. So it was at 20 volts. This was reading 20 volts on the meter, and then we plugged this in. It said 25 volts. But then later we plugged the meter into this directly, and it was reading almost 25 volts without
yeah.
this.
This
And then
is
the
what I
light turned
think.
on.
This is what I
Everything
think.
got better.
When we started
That's pretty amazing.
when we started this today, you said these were all at like 1.4. How much?
They were
had
like
you used them?
1.33 or something. All of them were. All these were like 1.33.
What if you charge these up again? These are rechargeable, correct?
Yeah, but those are going to be fully charged because
Okay.
these are charging those
Okay.
At
then
the
charge,
rate-
you know,
yeah,
everything up all
at the
way.
rate of powering this motor. So
Yeah.
these are charging these at the rate of powering this. So whatever this takes, we read this earlier, and what did it read?
8.9.
No,
Is that
when
what we're
we
talking?
connected to the 2 leads, it was 2 point something volts. Let's do it again.
Okay.
Remember? Okay, let's do it again. So let's do our. So right now we're not going to power any lights. We're just going to read voltage on each side of the motor, right?
Okay.
If I can find my correct leads to use.
More leads. I've got some here. Or you're just locating them on the table. Yeah. It
Yeah, I'm
gets
just trying to see
confusing
what
with
we
everything.
have. I'm just trying to see what we have here.
It makes a lot of sense when you see an automotive harness and it has 16 colors because
Yeah.
you're like, okay, this is tail light, this is rear left turn signal, this is front left turn signal, this is, you know, neutral safety switch, everything with a different color. We could play that game where you like name one part and then the other guy names another part with motorcycle wiring plugins. I think we
Okay.
can go for like 5 minutes.
So here's our motor. And so I'm going to plug the circuit in, and then I'm going to touch each side. Now what's interesting about this is even though it's a positive going in and a positive coming out, in other words, the positive of all these parallel AA batteries connected to the positive of all these series AA batteries, even though it's two positives, it's called splitting the positive. This is what it's referred to as. And there's a positive and negative on the meter reading when I connect to each side. So we're going to do that right now and just see what the voltage reads. Because when I said we're charging these batteries with these batteries in series at the rate of powering the load, I think I'm saying that right, but please confirm for yourself on Rick Friedrich's channel. It's under Loving Giving Path, under the circuit. Let's go ahead and do this and let's see what the voltage reads. So I'm going to go ahead and connect that.
That's
Oh wait, what's happening? Oh, it's not connected. I have to
Okay.
connect the meter. So
2.3 volts.
Yeah, so it's
Okay.
to me that's saying we're charging these batteries at 2.3 volts. We're charging these.
Okay.
Even though even though all these batteries add up to more than that, but we're charging those at the rate of powering this motor. And then this is spinning, so we're spinning a generator with that energy. The idea is that you can then put these batteries in series. Once these have depleted, you could put these in series and then charge that charge back to these again. That's the idea. Just look up Loving Giving Path on Rick Friedrich's channel to learn more about this. Okay, so, all right, are we done? Is that the last thing?
I think we did it.
Okay, all right, everyone. Thank you for
Cool.
visiting, and there'll be many more videos to come. Have a great evening.